Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli, the computer guy, and in today's class, I'm going to be showing you a project where we're going to have one Arduino Uno Wi-Fi talk directly to another Arduino Uno Wi-Fi. So we have done projects previously where we've had an Arduino Uno Wi-Fi that will post data up to a server. We will use PHP and MySQL database basically to parse and store the data that's been sent up to the server, and then the server will then send commands down to another Arduino Uno with Wi-Fi. And so that is great for a complicated system, right? If you need to store a lot of data values, if you need to be able to do real complicated processing based off of those values, it is definitely a great idea to have a server that your Arduino devices are going to be communicating through. But what if you have a simpler system, or for whatever reason you don't want to have a server involved? Well, one of the cool things that you can do with the Arduino Unos with Wi-Fi is you can actually have them communicate directly with each other, no server in between, and then have actions happen based off of the information that is being sent back and forth. So in today's project, what I'm going to be showing you is we're going to do a very simple project. We are going to have one Arduino Uno Wi-Fi that is going to be using an analog temperature sensor, so kind of like that default project that we always do. It's going to have an analog temperature sensor on it, and then based off of what that temperature sensor is reading, it will then send a command to a different Arduino Uno Wi-Fi, which will then turn on either a green or red LED based off of the command that it's received. The important thing to understand here is that there is no server in between. There's no PHP, there's no Python, there's no Node.js, anything like that. Basically, we're just simply using one Arduino to communicate directly with a different Arduino. All you need is the Wi-Fi network to be able to connect to. So before we dive deeper into the concepts that make this particular project work and actually take a look at the code, let's go over, take a look at the demonstration so you can visualize what we are trying to accomplish. Then I'll explain to you what's happening, and we'll take a look at the Arduino code. So here we are at my workbench, and this is the complete project. So although it's in a small area here, you can see that this is the complete project. So the important thing to understand here is both of these Arduinos are being powered on their own, so they're not connected to any outside computer. Basically, they are connecting to my wireless network, and we have the sensor. Basically, this is the sensor Arduino. This is sending commands over to the little dashboard Arduino over here. With the sensor Arduino, what I've done today is I've simply used a basic analog temperature sensor. Again, this is an easy way just to do some testing with a dynamic Arduino code. And then over here, all I've done is I have a green LED and a red LED plugged into digital pins 9 and 8, and based on the commands that this Arduino will receive from the sensor Arduino, the color of the LED will change. So since this is our temperature project, we now see that the color of the LED is currently green. So basically it's saying that right now we have a good temperature. If I simply, hold on to the analog temperature sensor here, after a couple of seconds, the temperature will go up, and now we can see that the red LED has turned on. So the green LED has turned off, the red LED has turned on. I want to take my finger off of the temperature sensor to let it cool down again. In a couple of seconds, the green LED should come on, and basically that way you can see that this is pulling in information from the analog temperature sensor. Depending on what the value of that information is, it is then sending a command basically to this little dashboard Arduino, and now we can see it's a green LED. So again, this is where you can have a sensor, depends on what sensor you want. Again, all this is a sensor. So this could be a humidity sensor, this could be a water sensor, this could be any number of sensors. Basically, the information is coming in. This Arduino is processing the information based off of if-else statements. It's then sending a value over here, and basically that is then lighting up either the green or the red, or you could have any number of other actions happen. So to make this project work today, we're basically going through and we're cannibalizing code that we've already used in previous projects. So in previous projects, we have had Arduinos who collect information from sensors and then send that information in a post up to a PHP server. And we've also had projects where that PHP server then sends commands down to the Arduino. Essentially what we're going through is we are cannibalizing components of the code we have used before. And so now instead of having the sensor Arduino sending information or values to a server, we are now sending those values directly to the other Arduino, and then that other Arduino is performing actions based off of that. So in order to understand how the sensor Arduino works, essentially what we're going to be doing is we're more or less going to be using the get method of posting data like we would use in many ways if we were posting to a server. So normally when you're using get to post to a server, you would give a variable name and the value for the variable. Today, basically, we are stripping that out and we are simply just giving a value. So only a single value is going to be sent over to the receiving Arduino. So essentially, we're not giving a variable name and a value. All we're going to be doing is sending a value. And so that value today is either going to be red or green. So all of the processing that will be happening today basically will be happening on the sensor Arduino. So what's going to happen is it's going to read the temperature from the analog temperature sensor that we have, and then based off of the value that temperature sensor is giving, whether it's 60 or whether it's 80, basically it'll determine, is it too high or is it where it should be. If it's too high, it will then send the value of red. So basically we're not doing variable equals red. All we're doing is we're sending red. So basically red will get sent here. And then when this picks up red, then it'll go, okay, then we're going to turn the red LED light on. If the temperature is below a certain level, this will send green. It will just send a text green. Basically, this will grab that green out of what's being sent to it, and then it will turn the green LED on. So basically all that processing for the temperature value coming in, and then what to do about the temperature value, that's actually happening on the sensor Arduino. Now over here, basically the code that we're going to be using, that we're going to be cannibalizing today, is where we have sent commands to the Arduino in the past, and essentially what we're going to be doing is we're going to be reading the string of the URL passed to this Arduino. So when you access an Arduino, right, so this has an IP address. This has an IP address of 10.0.1.16, and then you can have a /, and then you can have other stuff, after that /. And what you can do is you can have your Arduino parse or be able to read what is past that / and determine what should happen. So essentially, all that's going to be happening today is this is going to go to 10.0.1.16 / red. This is going to read, and if there is red in that URL, it will turn on the red LED. Or if this is green, 10.0.1.16 / green, this will be able to read the value passed to it that there is green there, and then it will turn the green LED on. So that's basically how this project works. So with that, let's go over and take a look at the code itself. So here we are at my demonstration system. I have the Arduino IDE open, and we have two different sketches here. So this is the Arduino to Arduino sensor. So this has the analog temperature sensor connected to it, and this is the Arduino to Arduino receiver. This is what will be receiving the values sent to it. It is important to understand that in the basic setup, there are differences. So there is some difference between how the sensor will be initially configured versus how the receiver will be initially configured. So the first thing for both of them is we're going to do the Wi-Fi 9 library. So this is an Arduino Uno with Wi-Fi version 2. So we need to basically have that include this library, so all of this stuff works. The next thing we're going to do is we're going to define the sensor pin is going to be A5. So this is the analog port that the analog temperature sensor is going to be connected to. Past that, we have the information that's required for connecting to the Wi-Fi network. So the SSID is basement. The password is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So whatever your SSID and password is what you'll put here. We create this status variable simply for the while loop while you're trying to connect to the Wi-Fi network. basically just a status there, nothing much to worry about. The next thing that we're going to do is we're also going to be creating a variable for server. So the server is where we are going to be sending our values. When we try to connect to a system and to send the values, this is what the variable is. And so for this, it's going to be 10.0.1.16. So 10.0.1.16 is the IP address that I'm going to be statically assigning within the receiver. So it's important with this part. It doesn't matter what the IP address scheme is. It could be 192.168.1. It could be 10.10 or 10, whatever. Whatever your scheme is, basically here is where you put the IP address of whatever it is that you're trying to connect to. So it's important to understand there's no forward slash, there's no additional information here. This is simply the IP address. Then we're going to go down, we're simply going to create the client. So this is for the Wi-Fi client. And then we're going to go into the initial setup. Now, one of the things I've started to do in the initial setup is just to visually show me when my little device has actually connected to the Wi-Fi network. I now have the built-in LED light turn on. So one of my problems is when I disconnect my little Arduino devices from a computer and I'm trying to connect them to the Wi-Fi network, how do I know when they're actually connected? Basically what I do now is I simply turn on the built-in LED pin after the while loop. Right? So this is the standard while loop of connecting to the Wi-Fi network. So essentially what I do here is I set the pin mode, and then after the while loop is finished, basically after the device has connected, the Arduino has connected to the Wi-Fi network, I then turn that little LED light on, just as a way to tell me that it's on. So something to think about there. Serial.begin 9600 like normal. This is the while loop to connect to the Wi-Fi network. It's the same code we always use. Then past that, we come down to the serial.print. So we'll serial.print out SSID and what the SSID is, what the IP address is, so on and so forth. So this is what you will be reading in the serial monitor. Same stuff like we always do. Then we're going to get down into loop itself. And again, frankly, most of this loop is the same kind of stuff you've seen before. Again, that's one of the things you have to understand about dealing with Arduino is once you start building code that works the way you want it to, one of the great things is you can start cannibalizing old code, right? Once you've created code that you like, then you just copy and paste a bunch of components out of different projects that you've created, right? Customize it a little bit so it all comes together. And that's one of the nice things. So here, again, this is the same code that we use for our temperature sensor normally. So this is how we actually get the value from the analog temperature sensor and turn it into a value for temperature Fahrenheit. So that's here, basically. So we're just getting that value. Then we're going to serial print, so out to the serial monitor for troubleshooting purposes, temp F, and then whatever the temperature Fahrenheit is. Past that, this is where we actually come down and we start sending values to the other Arduino that we have. So what we have here is we have an if statement. If temperature F is greater than 80, so if the temperature is above 80 degrees, right, do everything in here. We then do another if. So basically the important thing is if we can connect to the server at port 80. So when we say server is this variable up here. So if we can connect to 10.0.1.16 at port 80, then what we're going to do is we're going to serial print line. So on the serial monitor, we're going to print connected, just so we know what's happening. Then to client. So client, this is where we're printing out to the other Arduino, the other server, basically whatever is here at 10.0.1.16. So there we're going to simply print line get. So we're going to be using the get method. But here, all we're going to be doing is we're going to say /read. So you have to have the /. So basically this separates between the IP address and whatever other information you're sending. So you have to have the /. And then here, all we're going to be doing is read. So again, we're not doing color equals red. We're not doing temperature equals red. So a normal get, you would have the variable name equals value for the variable. We're not really doing that. We're just sending a value. We're just sending the value. So basically, we're just sending red, right? HTTP 1.0, just to say what type of information it is. Then we're doing client print line, basically blank, just to say, okay, there you go. That's all of your information. So if the temperature is above 80, we are simply going to be sending red, basically using the get method to the other Arduino. Else If temperature F is less than 80, basically the same code as up here, connect to the server at port 80, say that it's connected. Here we're going to be using the get method. Again, make sure you do the /, and then we're simply going to be sending green. So send green over, right? HTTP 1.0, and then print line. Then else, now again, there shouldn't be any reason for any else. Again, it should be either under 80 or above 80. But, when you're writing code, who the hell knows what's going to happen? Again, so for a troubleshooting procedure, basically this will simply do serial.println problem, and then you can try to figure out what is going on. Past that, if client is still connected, then client stop, and then simply delay for 1,000 milliseconds or for 1 second. So this is the code that is required to send from one Arduino to the other. The important thing here is basically we're using that get method like we have used in the past. But now instead of sending a variable with a value, essentially all we're doing is sending a value. So now let's go over and actually take a look at the receiver code. So if we take a look at the receiver code, we'll notice, again, basically we're just simply cannibalizing code that we've used in the past. So we're going to include the Wi-Fi 9 library. Then we're going to define digital pins. Green LED is going to be pin 8. Red LED is going to be pin 9. Same thing like when you normally attach LEDs. Then what we're going to do here is we're going to do the SSID as basement. The password equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like normal. But the thing now is we have to assign a static IP address. Again, remember, because one device has to communicate with the other device, in order to have that communication be possible, it has to know what the hell it's communicating with. So we're going to assign a static IP address. Do remember when you're assigning static IP addresses in the Arduino world, you separate the numbers with commas, not periods. That's an easy way to fat finger things and then screw things up. Then the status is going to be basically idle like before. And then here we are going to be setting up the server. So the Wi-Fi server is going to be at port 80. So if for some reason you want to modify what port that is, you could do that here. But basically we're saying Wi-Fi server port 80. The next thing that we're going to do is we're going to create a variable string, and then we're going to have the read string variable. So it's going to be a string variable that's going to be called read string. And so essentially what we're going to be doing is we are going to be parsing this to see whether it says red or whether it says green, and then doing something based off of that. Past here, we're then going to do the pin modes like we normally do. So this is the pin mode for that built-in LED, then pin mode for the green LED, pin mode for the red LED. Serial.begin like normal. Then we're going to have that while loop as it tries to connect to the Wi-Fi network. Once it has connected to the Wi-Fi network, we're then going to turn on the built-in LED so that we know that that has happened. We're going to Wi-Fi config. So basically we're going to feed a configuration for the IP address. So whatever IP address you have put here, that is now going to be the IP address for this particular device. And then we're going to do server.begin. So we're actually going to begin the server service on the Arduino. Serial.print, it will print out the SSID and the IP address, just so you have that on the serial monitor for troubleshooting purposes. Then we're going to come down here, and here's the mess of how we're going to actually parse the values that will be sent to the Arduino. So again, most of this is copy and paste. So everything here, you should have seen this before, and you're basically copy and pasting this from other projects where we have sent values to an Arduino. So Wi-Fi client equals server available. If client, basically run a serial.println, so we'll print out to the serial monitor, new client, while the client is connected, if the client is available. And this is basically where we go through and we parse the string that is being sent to the device. So basically 10.0.1.16 / something. That's how this all gets turned into that read string variable. And then what we're going to come down here, this is where all the interesting stuff is. So if read string, and then there is a function of index of. So basically you have read string. So what this is going to be 10.0.1.16 / red / green / Billy Bo Bob, right? So basically the index of function in Arduino looks for whatever you give it in the string. So basically it's going to say, hey, in this string that you've created, 10.0.1.16 / red, is green there? right? Or is red there? So if it's / green, it'll say green is there. And so what we're going to say is we're going to do digital write green LED high. So that turns a green LED on, a digital write red LED low, right? And then we're going to delay for one microsecond. Else if, so basically we're going to say else if read string index of, so in that string, if there is red, basically we're saying greater than 0. So if there is red, then turn the green LED off and turn the red LED on. Again, delay for 1 millisecond. Then past that, we're going to have an else. So what if somebody sends a value other than green or red? At this point, we're going to turn both the green LED and the red LED on to high. Then we're going to serial print problem. So we're going to simply print out the text problem. And then we're going to serial.print line, whatever the value of read string is, so you can see what somebody is sending to it. Then we're going to blank out read string. So once basically what's going to happen is here, this is going to assign the values to read string. So the URL that's being sent, this is what actually creates the read string, so you can read through it. Then we're going to parse, is there green, is there red, or is there something else? Then we're going to blank it out. So once that's been used, we need to blank it out so there's nothing in there. We're going to delay for 1 millisecond. Then we're going to stop the client. Then we're going to simply serial.print line out, client disconnected. And then we close a whole crap ton of different brackets here. So basically, this is how the code works. Again, the read string, it's going to be looking here for red or green. You could put whatever you want. You could put in green, yellow, blue. Again, notice this is an else if. So you can have a numerous different else if statements here. So you could have else if, else if, else if. So again, like for colors, let's say you wanted red and you wanted green and you wanted yellow and you wanted blue and you wanted purple and you wanted blah, 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 right? You could just simply do additional else ifs with looking for different text that is going to be sent to the Arduino device. Now, just so this kind of hits home, let me show you again how the command can simply be sent with a URL, and that might solidify how this project works for you a little bit better. Okay, so here we are back at the project again. So again, this is the receiver Arduino. This is connected to the LEDs, and this is the sensor Arduino. So basically what this is doing right now is the temperature down here in my lab environment is below 80 degrees. So this keeps sending green, 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 green. If I grab the temperature sensor, so I artificially spike the temperature up once it hits 80, what we'll see happen is the red LED will turn on, right? So this is now saying red, 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 red. And then if I take my finger off after a certain amount of time, the temperature will drop, and then it will start saying green, 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 green again. But it is important to understand how these commands are being sent, especially if you're worried about hacking, right? Everybody's worried about hacking. So to understand how the system can get hacked, let me simply unplug this. So basically at this point, this is no longer sending any values to the receiver. And you can also see that this might be a problem for you. So if the sensor is disconnected from the power, or for whatever reason stops sending values to the receiver Arduino, one of the problems with this project that you'll see is you'll notice that this green LED doesn't change. So this is based off of the last value received. If this dies, if this burns up in a fire or something else, this will stay green. So that's one of the things to be thinking about with problems for this particular project. Now, the other thing is, again, to understand how you can actually send commands to this little receiver Arduino. So remember, we're basically just sending the commands using an IP address. So 10.0.1.16, right? So this is the IP address of this receiver Arduino, / and then let's say we type red, right? So then we do that, and what we'll notice here is now that value has been sent to the Arduino. Again, if we want it to be green, we could simply type in green, and now we see it's green. Remember, when we did the if else statement, we also said if you receive anything other than red or green, so let's say we just send Billy Bob. Send Billy Bob! We hit enter. And now we see that both green and red are going off. So that's basically how this is working. So I'm showing you how this works using a web browser, but essentially that's what we're doing is we're simply trying to connect to that IP address with the // again, red, green, whatever value. And then this particular Arduino is doing something based off of that. So that could be a vulnerability with the system. Realistically, the real big vulnerability here is again that the Arduino will simply show you whatever the last value it received is. And so if the sensor Arduino loses power for some reason, again, this could be burning up in a fire. You could have a bonfire in your server room, but the last value that this received was green. So everything looks good. So something to think about there. So there you go. Now you know how to do Arduino to Arduino communication over your Wi-Fi network, and you don't need a server in between. You don't need to worry about PHP or Python or Node.js. You don't need to worry about MySQL databases or Linux permission or any of that kind of thing. Basically, you simply have your one Arduino communicating directly with another Arduino. Again, it's important to understand you could create a very complex system. You could have 20 or 30 Arduino Unos with Wi-Fi, all communicating back with any number of other Arduinos. You could come up with some complex system. So basically, you could come up with a system where you have these sensors. So you have the sensor Arduinos communicating with some kind of, let's say, call it a server Arduino. And then that server Arduino could parse values and then send commands over to a different Arduino to turn on a fan or turn on a pump, something like that. So basically, with this very simple level of communication, you could actually create a very complex infrastructure. Is it how I would create a complex infrastructure? No. Probably not. I would probably use a server with some kind of back-end language. That would most likely be a hell of a lot easier way of doing things, but it's important that you can create a bit of an infrastructure this way. The important things to think about with this particular project is, again, from an IP address standpoint, your sensors, basically anything sending information, can have a DHCP, basically a dynamically assigned IP address, because nobody's talking to it. It's talking to somebody else. It is important to understand, though, is any of the server, basically the receiver Arduinos, they do have to have a static IP address because those sensors have to know who the hell to talk to. Past that, again, from a security standpoint, from the rest of this, you do have to be thinking about how you write the code. What do you want to have happen if the receiver hasn't received information in a minute or two? Do you want some type of alert to go off? Do you want to build in some kind of security, some kind of password type system? So not only is red and green sent, but maybe some kind of password, some kind of authentication scheme, so somebody can't just, get on a web browser and just start typing in commands and start dorking with your system. Again, how you build that type of thing out, that's something that you have to think about and just, again, consider. That's one of the things like with security. One of the problems we run into with things like security is you can build all of this stuff relatively simply and it'll work forever, right? With these little Arduinos, you plug them in, as long as they've got power, they'll work for the next 1,000 years. So one of the problems you run into in the real world is there's what will work and then what is secure and what has a level of security that you care about, right? If you're sending information from, let's say, your garden, so let's say you have a garden moisture sensor and you're sending information just into a dashboard in your kitchen, you may not really worry about security that much. Oh no, somebody hacked my moisture sensor, right? That may not matter, so you're not worried about security. On the other hand, if it's temperature, environmental sensors in your server room or something else, at that point you may worry about it getting hacked or basically getting erroneous commands in, and therefore you may want to build some more complicated authentication and that kind of stuff. But that's things to worry about for other projects. So with this, essentially all we're doing is we're more or less using the get method as we've used in other projects to be able to send information using a URL. Basically the receiver Arduino reads the URL that it receives based off of what's in there, red, green, Billy Bo Bob, whatever else. It then has its own little if-else statements and then does things such as turn on the green or red LED. And that's basically how the project works. So, as always, I enjoy doing this class. I look forward to seeing you at the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.